This video is on the shape of the graphs of absolute value of x and x squared, and also on translations of graphs. So let's start by looking at what shape the graph of absolute value of x is. Absolute values just get rid of negative signs. So if I plug in -1, I'm going to get out 1. If I plug in 0, I get out 0. If I plug in 1, I also get out 1. If I plug in 2, I take the absolute value, I'm still left with 2. So what happens to this graph is I have these points -1, 1, 0, 0, 1, 1, and 2, 2. So what happens is the graph is these two lines that meet at the origin in this V shape. Okay? This is the shape of absolute value of x. Let's look at the shape of x squared. So we'll have x and we'll have x squared values. And I'll use the same numbers, -1, 0, 1, and 2. If I plug in -1 into x squared, -1 times -1 is going to be 1. If I plug in 0, 0 times 0 is 0. If I plug in 1, I get 1 times 1, which is 1. If I plug in 2, 2 times 2 is 4. So I get a graph that has these three same points. I have -1, 1, 0, 0, 1, 1, but I also have 2, 4. And as you can see, as I plug in bigger numbers, the output grows even faster than the absolute value. So it looks like this curved thing like that. That didn't go through that point. But that's the idea of the shapes of these graphs. Okay? Now we're going to talk about how can we translate them? How can we shift them around in the plane? So we can add, if we look at like x, we can add inside the function. So that would look like if I took x plus 3 and then squared it, right? I can add inside the squared part. Or it would look like maybe absolute value of x minus 7, right? I can do it inside. Okay, it's subtraction. We're going to think of them, right, kind of similar. They do a slightly different thing. Okay, or we can add outside of the function. So that would look like x squared plus 3, or it would look like absolute value of x and then subtract 7. Okay, and these are going to do different things to our function. Let's start with if we look at things that we're doing outside of the function, it's a little easier to think about. So if we think about adding something outside of the function, like y equals x squared plus 2, well, what is that going to do? Well, it's going to take all of the points. It'll take all of the points from the original function that I had, and it's just going to add 2 to them. So what happens is you start with this function, you started with this point at 0. And it'll shift up to be this orange point, 2 points up there. I should put marks this way too. Okay. I started with a point here. When I add 2 to the outside, I take this value, which was 1, and then I add 2 to it. It shifts up to 3. When I take the value that was at 1, I started at 1. Now I'm going to add 2. It shifts up here. And the same thing happens to the point that was at 2, 4. It gets shifted up to here. So when I add a number outside of my function, it shifts the graph up. If I take a look at what happens when I subtract outside of the function, so like y equals absolute value of x minus 1, what is that going to do? Well, it's going to take all of these numbers that I got out, and I'm just going to subtract 1. So it ends up shifting my graph down 1, and it ends up looking like this, because I just take all of my y values and I subtract 1 from them. Okay? Now we're going to look at what happens if we add inside the function. So let's look at the function absolute value of x plus 2. What this is doing is, you can think of it as I'm hitting the x values sooner, right? Because the x input, if I add a number, then I add something, I get to that value. So maybe we'll do a little bit of a chart. X, absolute value x plus 2. And I pick I'll pick -3, -2, -1, and 0. So I take -3, I plug it in this function, I add 2, I get -1, I get 1. I plug in -2, I'm taking the absolute value of 0, I get 0. I plug in -1, -1 plus 2 is 1, so the absolute value gives me 1. If I plug in 0, I take 0 plus 2 is 2, and take the absolute value, that's 2. So what I've done is I've taken my function and I've shifted it left by 2 units. Because I have a 2 here. So this shifts it left 2, and plus because it's left, right? So the other option we had was what happens if we subtract inside, and that does a similar thing. So if we take x minus 1 squared, that shifts to the right. And we can see this by plugging in some values. So x minus 1 squared. Values I want to plug in are 0, 1, 2, and 3. When I plug in 0, oh, got too low. When I plug in 0, I subtract 1. Negative 1 squared is 1. If I take 1 and I subtract 1, I get 0. Square that is 0. Plug in 2, I get 1. I plug in 3, I get 4. So you can see what that's done. This just shifted all of my points 1 unit, because this is a 1. I've shifted 1 unit to the right. And my graph ends up looking like this. Okay. That is how you shift a quadratic or an absolute value graph.